All right, so now we are starting the unit solving linear equations. So when you're solving linear equations just have a variable that doesn't have an exponent on it. So no exponents. We'll get to the ones with exponents later. Okay, so this is the idea. So blank plus 7 equals 12. So why don't you try and fill these in? All right. So hopefully you can kind of do these in your head. What plus 7 equals 12? So you can simply put that value in. What minus 3 equals 9? So, and then minus 5, 6. So hopefully you see that 6 times 2 is 12. That's times, I guess when I made this I didn't have a times. So that's supposed to be multiplication. So what times 5 is 35? And what times 6 is 18? So if you can answer those questions, you can solve these equations for the for the most part. So what we do, we fill the blank in with a variable. So instead of saying blank minus 6 equals 12, okay, so we could do probably these in our heads. These are pretty much the same problems that we said. So we know that 26 minus 6 equals 20. But that's a little non-mathematical. You can use your brain to do some of these things. I have no problem with that. But when the problems get longer and longer, we like to have a system. So what we do is we do what's called the inverse operation. So the inverse operation, it undoes the operation. And I don't mean like, a surgeon operation. I mean minus is an operation. So to undo it, we need to add 6. So negative 6 plus 6 is 0, so that goes away. And we're left with 26. So that's the idea behind this. We do the inverse operation. So the inverse operation for multiplication is division. So we divide by 2. So all we're trying to do when we're solving is we're trying to get the x all by itself. So we're trying to get rid of everything that's near the x. So here, 3 times x is 21. So you probably know that's 3 times 7. But the way that we get that is we divide. So if you understand the basic concept behind it, and you can do these smaller problems in your head, that's the exact same thing as over there, then each individual step that we're going to be doing shouldn't be as complicated. Now these are the steps for multi-step equations. So I just went from one step to multi-step in one slide. Okay, first of all, just realize we're doing this tomorrow. Okay, so we're going to start here today. So combine like terms, we've done that. Move variables from one side of the equal sign to the other. So when we move from one side to the other, we do the inverse operation. This is where that comes in. So combining like terms is just normal adding and subtracting or multiplying, whatever we happen to be doing. Okay? Move the variables first, move numbers, also inverse operation. Okay, and then we solve whatever two-step equations show up. Okay, that's operation. I am not neat today. I have to not neat this. Okay, solve each of the equations for the variables. So let's do step by step, okay? First, combine. So the first thing we're looking for is to combine like terms. Now, when we're talking about combining like terms, we're looking on either side of the equal sign. So we have to picture this like a balance. If we move something to one side, it's going to offset the balance. So here and here, there's no like terms. So we're good with that one. 2, we want to move the variable. So move x. So which one do we move? Really doesn't matter. I generally say move the smaller one. So this is 4x and this is 6x. 4x is smaller. But you can move either one you want as long as you're okay with negatives and positives. So in order to move it, we do the inverse operation. We want to take this entire thing and move it to the other side. But I can't just throw it there. That would make this unbalanced. It would make it tilt. I don't really have the whatever. So what we do is we do the inverse operation. So that means if I'm adding 4 here, I'm going to change it to minus. And what I'm doing is I'm keeping this level. I'm adding that negative 4x to both sides. So adding it to this side makes this one look nicer. And adding it to this side changes this to a 2x. So only when we cross over the equal sign do we do that inverse operation. So move variables. Oh, we just move variables. Move numbers. So the deal is we don't want to move this 7 this way. That's not good. Okay, what we want to do is we want to move everything now, this is a two-step equation, away from that x. So we want to first add the 7. That's the inverse operation. So I'm subtracting 7, so I add 7 to both sides, keeping it level. So that makes that 0. That goes away, and that makes that 14. So we're trying to just make this equation easier for us. So now this looks like just one of the other ones that we did. It's 2 times x, so if I want to get rid of that 2, I divide by 2. And that's it. You can take that and plug it back in to check it, but I'm not requiring that. Okay, first, I'm just going to start going faster. Combine. So when I say combine, we look on this side of the equal sign and that side of the equal sign separately. So these two are like terms, so I'm going to combine it. 8 minus 5 is 3. Okay. Now we move variables, but there's no variable. There's only one variable, so there's nothing to do. So we combined. Move x, or whatever, move whatever variable it is. But there's only one, and it's on all by itself, so we're done there. Now move numbers. So I'm going to take the 2, and remember we want to get everything away from that y. So I'm going to add 2 to both sides. Okay, and now it's one step. 3 times y, you should know, you could know that that's just 6. But in order to figure that out correctly, or algebraically, I guess, instead of mentally, that's the better word. Y equals 6. So same here. Here we go. So combine like terms. Okay, so we look on this side of the equal sign. There's 2 like terms here. I can combine them. We just combine like normal. So that's 5 minus 2 is 3. And we always do just one thing at a time. Just to keep us organized. Okay, move your x, or in this case, m. But m is on one side, so we're good. 3, move numbers. Okay, and when we move numbers, we add or subtract first. And then multiply or divide second. For our two-step equations, otherwise you'd have to divide the 10 and the 17 by 3. And that's going to get ucky. So we want to, when we divide, is that 7? So when we divide, we want to divide as little things as possible. If I divide, I have to divide everything by 3. Just like I'm subtracting 10 from everything, but that doesn't have the effect that dividing does. Dividing is kind of overtakes everything. So we want to make sure there's the least amount of things possible. And if we ever get a fraction, leave as a fraction. I'm sorry I'm taking this long. I'm trying to. Good. All right, let's do this again. 1, combine. So remember, on either side of the equal sign, do not cross the equal sign. Oops, sorry. Okay, Holy cow. So then we combine on this side of the equal sign. So we have like terms here and here. So we're going to combine those two. Signs don't change. It's -1 minus 7. So that's -8x minus 2. Nothing over here to combine, so that stays the same. Now we have x on both sides, so move x. So move the variable. Which one's smaller? You might say 7 is smaller, but the 8 is the smaller one. -8 is smaller than 7. So I like to move the smaller one. Okay, so add 8x to both sides. So when I combine like terms, I line it up like this, but I'm actually adding it to the entire side. So this entire side, the 8x gets eliminated. Then -7 plus 8 is 1x. Or you can just put x. The next line I will. Now we move our numbers. Now this is a two-step equation. So add or subtract first. So 6 is positive, so the inverse operation for +6 is -6. So we want that to be 0. So that's -8 equals x. There's nothing to divide here, so now we're done. Okay, so that's it. Give the ones a try at the end, and have a nice day.